Hi everyone, this is D. Lavanya. This video about design and analysis of algorithms. Kruskal's algorithm. Kruskal's algorithm is a greedy algorithm used to find the minimum spanning tree of a connected undirected graph. A minimum spanning tree is a subset of the edges in the graph that connects all the vertices together without forming a cycle and with the minimum possible total edge weight. Kruskal's algorithm works by sorting all the edges in a graph in non-decreasing order of their weights and then adding edges one by one to the MST, ensuring no cycle is formed. Steps of Kruskal's algorithm. Sort all the edges in the graph by their weights in non-decreasing order. Initialize a disjoint set data structure to manage connected components of the graph. Each vertex initially forms its own component. Iterate through the sorted edges. For each edge, check if the two vertices connected by the edge belong to the same component using the find operations. If they do, the edge would create a cycle, and so we skip this edge. If two vertices belongs to different components and add the edge to the MST and use the union operation to merge the components of these two vertices. Continue the process until the MST contains exactly V1 edges where V is the number of vertices in the graph. Key concepts. Disjoint set. This data structure is used to keep track of which vertices are in the same component. It supports two operations, find operation and union operation. Find operation determines the component to which a vertex belongs. Union operation merges the two components into one. Greedy choice at each step. We select the edge with the smallest weight that does not form a cycle, ensuring that MST grows in a greedy, optimal manner. Here is the time complexity. Sorting the edges takes order of E log E, where E is the number of edges. Example. In step 1, start with a weighted graph. In step 2, choose the edge with the least weight. If there are one more than one, choice any one. In step 3, choose the next shortest edge and add it. In step 4, choose the next shortest edge that does not create a cycle and add it. In step 5, again choose the next shortest edge that does not create a cycle and add it. In step 6, repeat until you have a spanning tree. This is the final spanning tree. This is the Python code and this is the output of the Kruskal's algorithm. In VS Code implementation of the Kruskal's algorithm is this is the code and the output is Kruskal's algorithm output. What we observed for the example. Now this is the prim's algorithm. Prim's algorithm is a greedy algorithm used to find the minimum spanning tree of a connected undirected graph. The Kruskal's algorithm, Prim's algorithm ensures that selected edges form a spanning tree with the minimum possible total weight. However, Prim's algorithm grows the MST form from an arbitrary starting vertex, one edge at a time, by expanding the tree. Steps of Prim's algorithm. Initialize. Select an arbitrary starting vertex. Set all the initial MST weight to 0 and mark the starting vertex as part of the MST. Use of priority. Min heap to keep the track of the next minimum weight edge that connects a vertex in the MST to a vertex outside of it. Iterate. Will there a vertex not yet included in the MST? Continue the process until the MST contains all the vertices in the graph. Key concepts. Greedy choice Prim's algorithms adds the minimum weight edge that connects the MST to a new vertex, ensuring an optimal solution. Priority queue. A priority queue is used to efficiently get the minimum weight edge at the each step that reduces the complexity of selecting the next stage. This is the time complexity. The time complexity is order of E log V. E is the order of number of edges and V is the number of vertices. Here is the example. In step 1, create a visited array to store all the visited vertices into it. This is the in step 2, since B is the least last visited, check for the least cost edge that is connected to the vertex B. B to A is the edge added to the spanning tree. In step 3, last visited edge is A to B is already in spanning tree. Check for the next least cost edge. Here A, hence A to E is added to the spanning tree. In step 4, since E is the last visited, check for the least cost edge that is connected to the vertices E. E to D is added to the spanning tree. Then step 5, since D is the last visited, check for the least cost edge that is connected to the vertex D. Here D to C is added to the spanning tree. Therefore, the minimum spanning tree is obtained with the minimum cost is 46. Python, here is the Python code and the output for the prim's algorithm. And this is implementation of the prim's algorithm is this is the Python code and the output is this. Prim's algorithm output is this one. Now, distracts algorithm. Dijkstra's algorithm is a greedy algorithm used to find the shortest path from a source vertex to all other vertices in a weighted directed graph. It can handle graphs with non-negative weights. Implementation of the prim's algorithm. This is the Python code and the output is this is the prim's algorithm output. The minimum cost is 26. Now, distress algorithm. Distress algorithm is a greedy algorithm used to find the shortest path from the source vertex to all the other vertices in a weighted directed graph. It can handle graphs with non-negative weights, which cannot have negative weights, and is widely used in the many real-world applications, including network retrieval, GPS navigation, and shortest path problems. Steps of distress algorithm. Initialization and relaxation. Initialization, set the distance to the source vertices as 0. Set the distance all the other vertices as infinity. Mark all vertices as unvisited. Use a priority queue to efficiently get the vertices with the smallest tentative distance. In relaxation, select a vertex with the smallest tentative distance from a priority queue. For each neighbor v of u, calculate the distance, total distance from a source to v u. Here, where u and v are the weight of the edges from u to v. Repeat the process until all the vertices have been visited or a priority queue is empty. In result, after the algorithm completes, the distance whereof will be contain the shortest distance from the source vertex to all the other vertices in the graph. These are the key concepts: grid query, priority queue, and the relaxation. The time complexity is using a binary heap. The time complexity order of v plus e of log v, where v is the number of vertices, e is the number of edges. Here is the example in step 1. Start from node 0 and mark node 0 as visited. Check for adjacent nodes. Here is in step 2. Mark node 1 as visited and add the distance. In step 3, Mark node 3 is visited after considering the optimal path and adding the distance. In step 4, mark 4 node 4 as visited after considering optimal path and add the distance. In final step 5, mark node 6 as visited and add the distance. So the shortest distance from the source vertex is 19, which is optimal one. And this is the pseudocode for the algorithm, and the implementation of the dijkstra algorithm is this one. This is the Python code, and now dijkstra algorithm output. This is the algorithm. This algorithm's output. Thank you.